Hello and welcome. In today's video, let's look at how to solve this problem. A stone is dropped from a cliff. What distance does it cover in the first 2 seconds? And in this problem, we are taking the acceleration due to gravity to be 10 meters per second squared. Is it going to be A, B, C, or D? Let's look at the solution. So we have a cliff and then this is the ground. Now we have a stone which is dropped from the top of the cliff. Being dropped means that the initial speed is equal to 0. Once this stone is dropped, what happens is that it is going to fall vertically downwards until it hits the ground. And it hits the ground with some final speed, V final, which is not 0. And why is this? Because we do have acceleration due to gravity, which is acting on this stone vertically downwards. Since this acceleration vector is in the same direction as the velocity vector, this stone is going to be speeding up until it hits the ground with this final velocity Vf not equal to 0. And in this problem, we are taking this value of g to be 10 meters per second squared. Now, we need to specify our coordinate system. So this is a purely vertical motion in one dimension. In other words, we can say this is a free fall motion. However, the physics is that this stone is dropped from rest. So initial velocity is equal to 0. And because the velocity vector is pointing downwards as well as the acceleration due to gravity vector pointing downwards, this stone is going to speed up until it hits the ground with some final velocity, which is Vf not equal to 0. All right. So the goal is to find the distance traveled by this stone after 2 seconds. So that would be our vertical displacement, delta y, in the first 2 seconds. What is that going to be? So in this problem, we are given the initial velocity, Vi, is equal to 0. We are given the acceleration of free fall to be 10 meters per second squared. We are also given the time to be 2 seconds. So applying our kinematics equations of motion, we can see that we can use delta y, which is the vertical displacement, is equal to 1/2 g t squared plus the initial speed times the time. But since this stone is dropped, the initial speed Vi is going to be 0. So this term here goes to 0. And this simplifies the problem a lot. In the next video, I'm going to talk about the case where the stone is tossed vertically downwards. Okay. So since we have that, then our equation is going to become delta y, which is the vertical displacement traveled, is going to be 1/2 gt squared. Now we need to specify our coordinate system. We are going to place the 0 or the stone at the 0 point. And any vector that is pointing vertically downwards is going to be negative. So along the negative y-axis, and then vertically upwards is going to be positive. So that is along the positive y-axis. So in this case, since acceleration due to gravity is pointing downwards, is going to be negative 10 meters per second squared. Now we can solve for our delta y after 2 seconds. So that is going to be delta y is equal to 1/2 g. So this time we use minus 10 meters per second squared and then t squared. So that is going to be 2 seconds squared. All right. So we can simplify this. Delta y is going to be minus. So this minus can come out 1/2 times 10 meters per second squared, and then times 2 squared is 4, and then second squared is second squared. All right. So we can clearly see that this second squared can be divided by this second squared to 1, right? So they cancel out to 1. So we can also see that 2 here, 1, and then 2 into 10 is going to be 5. All right. So with this, we can simplify our vertical displacement, which is delta y is equal to minus, so 1 times 5, which is 5, times 4, which is 20, and then meters. Okay, so that is the units. So this will give us the vertical displacement traveled by this stone in the first 2 seconds of being released from rest. However, this vertical displacement, which is a vector quantity consistent with our coordinate system, that any vector that points downwards is going to be negative. So we have negative 20 meters. So the absolute value is going to be the distance, d, and that is going to be 20 meters. And that is our final answer. So in this case, it is going to be option C, 20 meters. So this brings us to the end of this video. Until then, like, share, and also follow the page for more of such videos. I'll see you in the next one. Bye-bye.